What is happening, guys? Welcome to another daily data live stream. We are going to be going through and doing a little bit of deep language translation today. So if you've seen a couple of the live streams previously, we've been working on leveraging a transformer architecture to be able to translate languages from one language to another, which I personally think is an absolute deep learning superpower. I've been building a model based on this and a little bit based on this architecture that you can sort of see here in the Deep Learning with Python book. So we are going to be giving that a crack and really refining it. Because one of the things that we noticed when we went and tested it out last time was that there was a few bugs with the text vectorization layer. So I think we're going to try to debug some of those and get them all working today. But one other thing that you would have noticed is the new overlay. What do you think, guys? So I've been messing around and there's like some cool transitions when we're subbing from one screen to the other. I figured I'd mix it up and try to make things look a little bit slicker for you guys because I'm a big proponent of trying to get a little bit better every single day. So if you think about like the 1% theory, if you do something every day, if you aim to get 1% better every single day, then eventually that thing is going to stack up and you're going to be way better by the end of it. So yeah, that's why the overlays have come in. But let's have a quick chat. How's everyone doing? What time is it where I am? I am based in Sydney, so it is 5:34 p.m. right now. So I've just wrapped up work. I started a little bit earlier today so I could live stream a little bit more often. 5:34 p.m. My dude James, how you doing? What's happening, Ashwath? How you doing, PowerCube? Glad you like the layout. I'm really pumped you like it. Also, on-screen chat, right? Do you reckon it's cool to have on-screen chat while I'm coding? Like, I know there's a bunch of streamers that like they obviously stream for games, but like, is it cool to have on-screen chat while we're coding? I don't know. Or is it distracting? Give me a thumbs up or a thumbs down emote if you, depending on what you think. Leonard, working on your thesis. Amazing. Ashley, how you doing? Thanks, glad that you like it. Oh, wait, Leonard, we are going to show some transitions. I mean, it's just one transition, but you'll see it in a sec. How you doing, Christoph? 9:30 a.m. in Warsaw. Nice. Alrighty, cool. I think let's get into it and we'll take it a little bit. We'll do a little bit more coding in this one because I think I wanted to do a little bit more coding as per usual, but I'm looking at the other camera. I'm meant to be looking at this one. I want to do a little bit more coding in this one because I really want to get this tutorial sort of done and dusted so we can actually stitch it together as one big video and actually get some more deep learning content out there. But now I've got this book. Last time I was meant to have this book near me so I could actually go and reference it, and you can see that there's this little flap thing here. That is because that is bookmarked to the sequence to sequence learning page of transformers. Check out that architecture there. That's effectively what we're going to be trying to build out and debug why ours was just throwing out unknown tokens. Okay, let's kick this bad boy off. Are you ready for this? We're going to do another transition. Ooh, what'd you think? Yeah? Alrighty, cool. So we are going to be starting to code. On a scale of 1 to 10, how good am I with Java? Terrible. Never coded in Java in my entire life. Although, once you know one language, it's relatively straightforward to pick up with another language. So, I mean, I think that's a big thing. Like, if you start coding in one language, I promise this isn't beer. If you start coding in one language, when you go and transition to another beer, or to another, no, another beer. When you go and transition to another coding language, it definitely helps out a lot more. Alrighty, cool. Let's get coding. So I'm going to open up my existing notebook. Let me bring this over here so I can sounds a little bit better. All right, so it is Transformer LTT. Oh yeah, also thumbs up, thumbs down if you want live chat on the coding screen. So like, I don't know if you can see, but like, so this is me right here. Should I put like the coding live chat just up here? I mean, I think it'll look pretty cool, but don't want it to distract from the coding if we are focused on coding. Okay, so what was wrong with this last time? So if we scroll on down, the thing that went wrong is when we went and made, so when we went and made predictions, it was passing through our start token, which is perfectly okay. We expect it to start with start, but then it was just predicting unknown unknown. So these unknown unknowns become a little bit problematic because that's not a real translation. And what's got me thinking, I don't know if this is definitely the issue, but what's got me thinking, what I'm thinking is happening is that we have a absolute ton of words in our population of text-based data, and our text vectorization layer does not have a sufficient number of tokens to handle that. Either that or there's a problem with the model architecture. So the first thing that I'm going to try to do in terms of debug, and this is actually how I debug real time. First thing that I think we should try to do is try it out with a lighter weight data sets rather than trying it out with this monster Opus data set that I'm working on over here. So this is from Tensorflow data sets. If we go to, this is probably not zoomed in yet. 150, 175, 175 looks okay. Tensorflow data sets, Opus. I think it's Opus. Yeah, so Opus is like, I was just Googling around to find out what good data sets there were, but Opus is a collection of translated text from the web, and it's massive, right? Like there are a absolute ton of samples available in here. Like there's one for law documents. Oh, I didn't even know there was that. That is cool. There you go. The Quran, IT documents will be sick because you could do like a big part of what I do, or sometimes not, I don't do it as much every day, but we answer RFP, so questions about software. So I wonder if you could use that. Interesting. All right. So I don't want to use this though, because this is a monster and it makes me think that we just have way too many tokens. Well, let's actually explore. So if I go and import my drive, connect. All right, so Noor, the name of the book is Deep Learning with Python by Francois Chollet. That's what it is. I don't know if you can see that, hopefully. Yes, connect to Google Drive. Yep. Allow. Thumbs up for chat while coding. Okay, I'll go and set that up tomorrow. It's not that hard. I just didn't know. Okay, so we are then going to import our dependencies, and then because we got to flatten it, and this is the problem. I don't know how to get the number of unique tokens, but we could loop through and just append, but that is not an efficient way to do it. How many tokens do I have in my text vectorization layer? So I'm capping it at 20,000. Okay. I'm just going to run through a bunch of samples and see if we're getting those unknowns. So this takes a little while to download because it's a monster data set. The other thing that I'm thinking about doing is actually getting the whiteboard that I typically use, or the iPad, and hooking it up. We can do live breakdown boards. Also, this entire thing is eventually going to become a full-blown tutorial, so it'll just be exactly very similar to what you see on the channel already in terms of tutorials. Okay, so we're downloading some data now. So let me run you through some of this. So when you're working with the TensorFlow dataset, you can run, or well, in this particular case, I've run TFDS, which is bringing in TensorFlow datasets from up here. And then I'm looking at the Translate API, which is over here. So the Translate API, and then we're grabbing Opus, which is there. So translate tfds.translate.opus. So that's how we're getting to this data set. And then we're running opus.config. And then I believe we are able to specify what language pair that we want. So in this case, we've got German and English. Takes a little while to download. So Shivam, your question, I want to join IBM as an AI engineer or data scientist, and this is my dream company. How do I join? I have an in-depth knowledge of deep learning. Keep applying. So get experience, keep applying. So that's exactly what I did. I don't know if you've watched the video about where I talk about it, but I applied a ton of times to a ton of companies. I did a ton of interviews. I built a bunch of assets, made videos. You got to keep trying. If you get knocked back, you got to keep going at it to really truly get there. It's not a slow process. I mean, anything worth doing is not going to be. But just keep in mind, you got to keep going at it. All right, cool. So I really should get a camera so you guys can see this book. But there is a transformer decoder architecture out here, and we pass in. I'm pretty sure I've already got this set up the same. So we pass in the source and we pass the target, and the target is offset by 1 step, which I already do. So that bit should be okay. I don't know if you guys have seen this architecture before, but let me actually show you. So transformer language translation architecture. This. So we are passing in the inputs, we're passing in the outputs, and we've effectively created what you can see here. Pretty sure we've got a softmax as well. So this is already, my head's blocking this, I realize now. If I bring it to this side. So we're effectively building this architecture over here. So you can see it's pretty sophisticated. So we've got the multi-head attention layers, we've got an addition plus a layer norm, and 2 sequential neural networks or feed-forward networks as well. Oh, this is my favorite question. Why are you using TensorFlow? I heard Google engineers are moving from TensorFlow to JAX. Okay, so there is always going to be a, let me jump over to chat. While is the dataset still downloading? Dataset still downloading. Okay, ideally you'll be able to see this chat question. So One Pod Dish just asked the question. So why are you moving to why are you using TensorFlow? I heard the Google engineers are moving from TensorFlow to JAX or something else. There is always going to be a new library. There's always going to be a new module. But if you learn one and you become proficient or somewhat proficient in it, you don't need to be afraid to continue using that. If you've still got a reasonable level of performance, it's still working, there's always going to be a new state of the art. I think that's the key thing to keep in mind. There's always going to be some new framework out. There's always going to be a new language. But keep in mind the cost of switching, or the switching cost to go between libraries. If you keep moving to a new module or a new library each and every single time, you're never going to get the chance to become proficient. I'm still continuously learning with TensorFlow, and there's still a huge open source community around TensorFlow, hence why I keep using it. I have looked at PyTorch, but as of right now, I can't really see a huge reason to move all of my development, particularly in deep learning, from TensorFlow to PyTorch. Like, unless there's becomes a point where TensorFlow just completely goes down the drain, I can't see myself shifting there. I mean, if at some point that you guys want me to do PyTorch tutorials, I'll do it for you guys. But for me, I'm like, TensorFlow still works. It's still performant. It still allows me to do everything that I need to do. There's really no impetus for me to move over right now. Are lives available to watch yet later? Of course. These are all made available as soon as they finish. So just if you need a drop off, or you need to go do something, need to have dinner or have breakfast, depending on wherever you are, don't worry about it. I publish all of these live straight after. Okay. So we are going to be digging through this. So I just want to test out and ensure that the text vectorization is working. So if I build the data set, we'll do some more chat later. All right, so DS is NumPy iterator. Okay. So you would have seen me use the dot as NumPy iterator a ton of times, right? So this is the ability to iterate through a part of a TensorFlow dataset. I'm probably going to do a video on TensorFlow datasets, but so ds.asNumPy iterator.next. So that is returning the German component, so DE, and this is the typical representation for a unpreprocessed translation data set. So we've got the German component here, we've got the English component here. Then what we're going to do is we're actually creating two different data sets here. So a source, which is grabbing the English component. Talking this through to you guys actually helps me quite a fair bit. So if I type in source.as numpy iterator.next, it should give me just the English component. So that is just that bit there, right? Then if I go and type in target.as numpy iterator .next, should give me just the German component with start and end appended to it. So you can see we've got start there, we've got end there. Okay, we are looking okay. So that bit makes sense, that works. Then we run it through the text, or we're training our text vectorizer. Oh, hold on. That is probably it. We are only taking the first 10,000 samples and passing it to the vectorizer. But that would mean it would take a ton of time to, and we're saying, hold on, how long is the, I think we found the issue, guys. Source. I don't remember doing that. Anyway, there you go. It's always fun. Oh, okay. So we have 1 million samples in our data set, and I'm only taking 10,000 samples and passing that through to our vectorizer. So it has no idea. It is only seeing like what 1% of our possible potential data set when it's actually training the vectorizer. Oh, I hope that's what it is. I mean, because that would mean that we get a ton of unknown responses or unknown tokens. How do we recreate this issue? So if I were to go, all right, let's make it even worse. So if I was to only give it, let's say 100 samples from the source and target data sets. So source.take effectively cuts down the amount of data inside of your data set. Actually, I do remember where I did this. So when I was in Bali, it was taking a ton of time to train the vectorizer, or for the vectorizer to actually generate or learn effectively. And I cut it down. But that would have meant that when I actually go and train, there's not gonna be a sufficient number of tokens in the vector or in the text vectorization layer to actually go and appropriately convert those tokens. Oh, okay, that makes a ton more sense. So now if I go en vectorizer and pass through, let's get this, let's get an English sequence. So this, actually I could just do, so we've already got our English source data set. Got as numpy iterator.next. So if I grab that, pass it through our vectorizer, does it need to be inside of an array? Okay. So what is unknown? So I can type in en vectorizer. Whoop. Vectorizer dot what is it? Is it get vocab? Get vocabulary down there. Boom. English vocab. It's funny, like you write some code and then you look back at it and you're like, why is that happening? You're like, that shouldn't be happening. Okay. So what is the number for unknown? What is the smartest way to do this? If I go to the en vectorizer, can I just pass through UNK? It's in square brackets. All right, so 1. So 1 is unknown. Let's make a note. Token ID 1 is the unknown token. All right, cool. That's good. So now that we know that, let's actually take a look here. We don't have any unknown tokens there. Interesting. What if I go and run it again? That is because we need to take this. It would be okay for the... Okay, so let's think this through. So if I go and take, it would not present an issue if I just go and run the iterator like that, because it is going to have already captured the first 100. So if I type in .skip 100 as numpy iterator, so this means it'll take the 101st sample. If we get a ton of unknowns here, then we know we've got, all right, so we've got, what is the, let's take a look at the actual text. Sample. I'm just trying to prove my theory right, because I want to be able to sort this out and at least get it running for you guys. In invented name. Okay, so invented name clearly have tokens. So let's just quickly double check that. So if I go and run vocab and get back token 97. It's called English vocab, my bad. All right, so invented is definitely in there. 87 should be name. Okay, so that's good. So what if I skipped 50,000? What's the sample text there? So medicinal products subject to medical prescription. So if I now pass that sample text to our vectorizer. Oh, that is it, guys. That was the issue. Take a look. So the fact... All right, so let me replay this back to you. So if we scroll on all the way down, you can see that when we went and ran our translator, we were getting unknown tokens returned, right? So it was predicting that when I'm translating the word mine or the sentence, my name is Nicholas, it was telling me that this is the translation. So unknown, unknown. But we clearly know that that is not the correct appropriate translation from, regardless of whether you know German or not. We actually, and that's because of this issue that we just found out here. So because our text vectorization layer has not seen enough words, it has no idea of the entire population that it's going to see. So it is just going to assign an unknown token. That is the issue. So the way to fix this is by allowing our text vectorization layer to see more samples. Now, this is obviously going to take a ton of time to train, so I'm probably not, but I'm almost 99% sure that that's the issue, because I've gone through the architecture about 1 billion times. So now, if I don't limit, this is obviously going to take a while, but if I don't limit the source and don't limit the target here, that means that our text vectorization layer is going to see 1 million samples each, which is going to take a while to train. But if I run this, we might have to review results tomorrow. I figured that it was going to be a not... All right, so it's running now. I think we're good. Okay. All right, I think we're good. We don't need this code. We can get rid of that. We can get rid of that, get rid of that, get rid of that, and get rid of that. So that should fix. So the other thing that we could have done is just taken a smaller data set. Hey, I'm wondering if we should take a smaller data set, because this is going to take a ton of time to train. Do I have background execution? I've got background execution. Maybe I'll let this train overnight and we'll see it tomorrow. We'll need to save the vectorizer as well, though, because otherwise I really don't want to have to go adapt it every single time. So let's learn how to do that. Save a text vectorization layer TensorFlow. Interesting. Oh, so they just pickle it. What? Is that right? That seems... There is nothing to save it. Okay, I guess we're pickling it. All right. So we are going to import pickle. Let's actually just test it on a smaller data set to begin with, or test it that we can save it on a smaller data set. So if I run, so source.take 100, and that way I can share the trained text vectorization layer with you guys as well. So if I go and run that, import pickle, what is it? En vectorizer is not defined. Yes, it is. Oh, did I restart the runtime? No. Bloody hell. Okay. Can you create a set of all words and run vectorize? Honestly, I'm thinking the faster route to do this is just to cut down and run a smaller data set. Let's actually duplicate this. Let's go and duplicate. So rather than running it, because I really just want to validate that we can do the entire thing end to end. So how do we duplicate this? New notebook, edit. I thought we could. Okay, save a copy in Drive. Let's actually swap out a data set. What data set does Francois use? So let's take a look. A bit aggressive with this book. Poor book. He uses... I have no idea. Machine. He's using the Spanish to English dataset from the Google API. Let's see if we can grab that. Okay, so we can run wget https or http storage dot. This is debugging on the fly, guys. So let me quickly just replay what's happened. So we found the issue, or at least I think we found the issue, which was our translation model was returning unknown tokens. And the reason that I think we found that issue is because when we went and trained our vectorizer, and think of your vectorizers converting text or natural language. Let me actually, I want to keep the code on screen. Because we convert text to numbers. Now, if our text vectorizer does not have the appropriate capacity or has not seen a number of weird words, it's just going to return unknown. So that's the default fallback action for the text vectorization layer. Now, when we went and trained it initially, I only passed through a really small subset of data to our text vectorization layer, which meant that it probably wouldn't have been able to see a whole bunch of weird words. So when our data was passed through the text vectorization layer and trained, then our deep learning model would have recognized that and been like, yeah, unknown is a perfectly valid token because that is what our test data, or that is what our output token actually looks like. So now the debate that I'm going, or the mental debate that I'm having with myself right now is, do I go and try to train this monster text vectorization layer, or do we just cut down the data set and use a slightly smaller data set, because that's going to make life easier for anyone that actually tries to go and do this tutorial in the end. Like I could train this and actually pass through, save down those layers. I mean, what do you guys think? Should I cut down the data set and make it a little bit more reasonable, or work through and actually try to save those vectorization layers? So like that's what I'm going through right now. Can you create a set of all words and run vectorize? You can, but it's a bit of a pain with the TensorFlow datasets because it's intended to run as a pipeline. You don't just get one monster data set. So in Francois Chollet's book, he's actually got a smaller subset of data, I believe. So, and that's what I'm going to try to get now and then go from there. But let's do this. The storage.google apis.com/download .tensorflow .org /data / save the vectorization layer. Yeah, we might do that, but let's try this for now. eng.zip. Let me just run through that. storage.googleapis.com/download.tensorflow.org. Yep. /data/spa. Is this, can I just Google this? Spa English.zip. Yeah, it is. It's up here. Oh, so the tutorial that I'm actually looking at in the book is available here. I'll throw it in the chat if you guys want it. There's this data set, so it's literally this. Let's make sure we got it right. Okay, we got it. All right, so then we can unzip it. Unzip spa english.zip. Oh god, unzip. It's unzip as unzip in New Zealander. All right, cool. What's happening? Okay, so let's take a look at this. So this is our data set. That is taking a while to visualize. How big is this? Oh, this might be huge as well. While that downloads, let's go through the chat. Alrighty, what's happening? Oh, should probably move that out of the way so we can see. How can we use Hugging Face Tokenizer and text vectorization? I don't know if they actually play well together. I know that there is, yeah, actually unzip. I know that they've got their own vectorization model. I don't know if it actually works with TensorFlow. I mean, maybe, I don't know. I can go and have a look after this. Let me move the chat onto this screen so I can see it. Hey, Innocent, how you doing? Hey, do you have any, so this is from Don't Even Bother. Hey, do you have any plans of just doing a Q&A video anytime soon? Yeah, if you want me to do it, I'll throw up a poll in the community tab on YouTube after this. You let me know, just throw in your questions. I'm more than happy to answer them, or just do a Q&A video rather than a live stream. Although I'm happy to answer your questions here as well. Lily, how you doing? Love that you love the new setup. Will be dope to do a lip reading algorithm. I heard the accuracy for it doesn't surpass 50%. That'd be interesting, right? Like to get one that is better than human performance. Like, because like 50%, I think it'd be pretty good. Like I can't lip read for crap, but it'd be interesting to see what that actually looks like. All right, we're going to go back to code because the data set has now downloaded. All right, so this is our data set. Let's take a look. I think this is huge. Okay, so it looks like it's space delimited. Right, so we've got what's the exclamation marks represent? Okay. I feel like we should be able to read this. So if I go and run, this will need to be done slightly different. So from TensorFlow .data, actually I can just import TensorFlow. I don't need to do that. Let's just mount the drive. Connect to Google. What's the time? Oh, damn. Gotta wrap this up soon. I'm determined to get this working though. Okay, so that's fine. So then let's import TensorFlow. I'm just gonna add import, making sure you can see that, import TensorFlow STF. Then rather than leveraging the existing Opus dataset thing, I want to import Spark. So it's gonna, let's write down the file path to file. path equals spar os.path.join, and it's going to be spar eng bar.text. With open file path, and then r as f data equals f dot read lines. TensorFlow IO wrapper. What is it? Is it F or is it read or read lines? There we go. Data. Probably going to blow out our memory now. Let's take a look at how Francois is handling this. So he's splitting by tab. Okay, hold on. Let's just run through this. f.read.split, and then he's grabbing the first one .split, splitting by new line, and he's cutting it off at -1. So what is that doing? Oh, he's cutting off the comma. Okay. So that will cut off the comma between each one of those lines. Oh, what has that actually done? He's grabbing. What is the last thing? Okay, this must clearly be something in the last data set or the last sample that we don't want for that particular data set. All right, and then we're going to split it into text pairs. So splitting each one into English, Spanish, and then appending. All right, that I can do. No stress. Okay, so that's all of our data. So this is the data set that is actually recommended in this tutorial. The official Keras one. So if you want to go check that out, by all means, go through it. All right, so we're going to go for line in data, and then we're going to create a data set. They call them text pairs, and it's an empty array. And so let's think of this through. So I just want to return one sample. So data 0. Cool. All right. So what we're going to do is we are going to unpack this. So we need to then go line.split, and we are going to tab delimit it because you can see it's split by a tab there. Let's do that. Let's actually just do the first one, right? And that is going to return back. We'll have the English example and the Spanish example. What happened there? For line.split. No, that's not cool. So how has he split it, done it, tab delimited? Need to practice my text. I'll go through my Python memory path. I'm clearly a bit rusty. So that should work. Oh no, because I've got one sample. Oh, my bad. I know. Okay, so that's split successfully. So, all right, so we've split that, and then what we want to do is pass that back into our array. So we're going to have z. What's the best way to do this? So have all of the one sample should be, would we not just append that back? Yeah, all right. We're going to wing this. So this is our sample equals that. Line dot split, remove that. Text pairs dot append text. We want to append our sample to that. So that means we'll have all of our data sets inside of one monster array. We'll have, and each sample is 2 words. So the first one is the Spanish word. The second one is the, first one is the English word. Second one is the Spanish word. So if I go and run that, if we now take a look at our first text pair, text pairs, right? So we've got go and is there. Then let's get rid of that. We don't need that. Don't really need that. Then we need to convert it into a TensorFlow data set. So to do this, we can write data set equals TensorFlow dot or tf dot tf dot data dot data sets data set dot from tensor slices. And then I think we can pass through text pairs. Let's take a look at that for now. So then I can go dataset. I should have called this DS. That way we can just reuse this code. All right, so let's take a look at that. All right, so we've got an array. The first part of that array is the English bit. The second part is the Spanish bit. Then what we're going to want to do is we're going to grab the source, and then because we're dealing with an array rather than a dictionary, we can just grab the first bit, which is going to be index 0. Then the second bit, we are going to be grabbing index 1. So we should be able to do, I'm mentally going through this to make sure that that works. So start, I think that'll be okay. Then we're going to run it through the vectorizer, or instantiate our vectorizer. What's the length? How many samples do we have? Source is 2. No, we've cut something down because we need all of our data sets up here. Run through that. Take a look at our length again. All right, so we've got 118,964 samples now. So, okay, so we go and run our vectorizer there. That works. And then how long is this going to take to train? Hopefully not too long. We want to remove these because remember that's what was the driver of our errors. Maybe this will run quick, who knows? Alrighty, what's happening? All right, so what about TensorFlow Lite and how does it work? So TensorFlow Lite, I believe, is intended for edge devices, so like Jetson Nanos. I've actually got a Jetson Nano that I'm going to be playing around with soon, so just keep that in mind. So I do have some stuff happening here. This thing is still training by the looks of it. Can we change the default version of Python in Colab? I don't know. I haven't looked at that. Which book am I using? I think I linked to it or didn't link to it, but it's Deep Learning with Python by F Chollet. Loving that you're enjoying these tutorials. This is going to take a little while. Either way, I think what I'm going to do is I'm just going to go with the big data set. Go with the big data set, and then I will work out how to save it. Because we've got to wrap up this live stream sooner rather than later. Yeah, this is going to take a while to run by the looks of it. Either way. Alrighty. Look, guys, as per usual, I just wanted to say a huge thank you for tuning in to the Daily Data live stream. I'm hoping you're enjoying this and you're learning a little bit about what it's like to work with data out there in the real world. As you can see, it does take a bit of time and infrastructure can complicate things, as well as working with massive data sets. Hopefully you have enjoyed this live stream. I'll quickly check in. Oh, it looks like you can change the Python version. Anyway, on that note, I will leave it there. Thank you so much for tuning in, guys. Hopefully you've enjoyed this. I'll probably sort this out and give you some feedback tomorrow to let you know how it went. But on that note, thanks again for tuning in. A peace.